asked to find the range of f of x. Now, first of all, I'm just going to identify that it's a positive quadratic, a happy quadratic. It's going to look something like this. So the range is going to be all possible values above this minimum point, i.e. we want to find the minimum. We can do this in two ways. You could differentiate because you can always find stationary points by differentiating, and we'll talk about that in a minute. Or we could complete the square. So I'm going to complete the square here. Factorize out the 2. It's going to be, actually, sorry, there's no extra numbers, so I can just write 2x squared plus 3x. And then complete the square on x squared plus 3x. It's going to be x plus 3 over 2 squared. Remember, you have the 3. And then we minus 9 over 4. Okay, for more information on like where that comes from, look at other completing the square questions like AS questions and so on. Put the brackets in. Hopefully you're happy with that. And then multiply it back out by 2, so it'd be 9 over 2. Right, now we're nearly there. So this thing here is always going to be greater or equal to 0. It can never be negative. And so overall, the function is going to be greater or equal to minus 9 over 2. Because the smallest that the red bit underlined could be would be 0. So the smallest the whole thing could be would be minus 9 over 2. Otherwise, it's always going to be bigger. And that is the range. F of x must be greater or equal to minus 9 over 2. Now, if you're not a fan of completing the square, let's differentiate. So we can do f dash x is equal to 4x plus 6 equals 0 for stationary points. You could argue that we know it's a positive quadratic, so we know it's going to be a minimum. Like we don't need to do the second derivative or anything. So x is then going to be minus 6 over 4 or minus 3 over 2. And then it's just a case of substituting that back in to the original function. 2 times minus 3 over 2 squared, so 9 over 4, plus 6 times minus 3 over 2. It's going to be, I mean, you can put it in your calculator, it's going to be 9 over 2 minus 9, I think, which is minus 9 over 2. So that is the stationary point, and again, we would get f of x is greater or equal to that. Do you have a reason why f has no inverse? So an inverse, for a function to have an inverse, it has to be one-to-one, basically. A value of x has to map onto a single value of y. So that is immediately not true here because it's a quadratic. For example, if we draw a line across here, there are 2 values of x that are going to go to this value of y. So we just need to say it is not one-to-one. In fact, in this case, it is many to one. So 2 values of x are going to a single value of y. So you could write that instead, which means when you try to do the opposite mapping or the inverse, it would become 1 to many, and that is not defined as a function. So for the next part, we're given this equation, and we're asked to determine the value of a. So first up, let's work out what g of minus 2 is. G of x is 3x plus 2. Actually, let me just write that up here because it's gone off the screen. So g of minus 2 is going to be minus 6 plus 2 minus 4, which means f of g of minus 2 is actually f of minus 4. So it's 2 times 16 plus 6 times minus 4. It's going to be 32 minus 24, which is going to give 8. So if that with the left-hand side, it's going to be 8. Okay, now we're going to need to work out the inverse function for g. So I'm going to let y equal 3x plus 2. So what is happening here is that we have an x, and it is being times through by 3, and then we are adding 2 to get y. So the inverse is what we do to go the opposite way. We would start out, well, let's start out with y, for example, just for the moment. We would actually minus 2, and then we would divide by 3 to go the opposite way, and that would take us back to x. And that actually gives us our inverse. Another way of doing it here is to rearrange and make x the subject. So it would be y minus 2 over 3. So that tells us how to get from y back to x. The inverse, we always actually put x in as our input, so we just basically replace y now back by x. Sometimes people do that right at the start. They like take the y plus 3x plus 2, swap the y and the x around right at that point. So it doesn't, get the same outcome. So that is our inverse. That's it's a minus 1. It looks like a f dash x, doesn't it? It's meant to be minus 1. So, apologies, that's actually g minus 1. That means that g minus 1 of a is going to be a minus 2 over 3, and it's going to equal h from before, because remember, that is the equation that we had up here. So we're told that a is a constant and determine the value. Okay, there's no restrictions or anything. So a minus 2 is going to be 24, and therefore a is going to be 26. On to the final part of this question. We're asked to determine the set of values of x for which f of x is greater than g of x. So remember from the start, we had f of x is 2x squared plus 6x. I'm interested in where this is greater than 3x plus 2. We have ourselves a quadratic inequality. So I'm going to do this without a calculator, and I'll show you how I could do it with. So 2x squared, we can minus the 3x, so plus 3x minus 2 is going to be greater than 0. And now we can focus on this as being a sort of function, y equals. So we can try and find the roots and then sketch it. So if it's going to factorize, which we're going to try, it's going to be 2x and x to get the 2x squared. To get a 2, forget the minus 2 for the moment, we're going to need a 1 and a 2. If I put 2 there and 1 here, I'll get 4x and x. I should be able to get a plus 3x if I make this plus and this minus. So the roots of the equation are a half and minus 2. So I draw my sketch, got minus 2 here, a half here, so the quadratic will look a little bit like this. Now we're interested, okay, we've gone from here, but we've turned it into a quadratic that's greater than 0. So I'm interested in where the quadratic is above the y-axis, here and here. So I've got x is going to be less than minus 2, or x is going to be greater than a half. Now that is normal notation, but we're being asked to write it in set notation, which means we have to slightly alter it to the set of x such that x is less than minus 2, and then do a union. This is basically the same as or, but in set notation, the set of x such that x is greater than a half. Okay, that is our answer. Just to quickly show you how you do it using your calculator, because it doesn't say show detailed reasoning, so you would be okay to just basically substitute it in, not into equation function, but into inequality. It's degree 2 because it's a quadratic. Then we've rearranged it into this purple one here, so it's a greater than, so it's going to be first one, and then you can just put in 2, not 6, sorry, 3, and minus 2, which gives these two answers. Nice one.